Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin-Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello and welcome everybody to this week's episode of the DooDoo Divas Smells Like Money podcast. Today, we are visiting with John Moody, who is the Director of Sales for North America for Primus Line. So welcome to the show, John.
Thank you very much, Susan. Thank you. Hello to everybody, and thanks for having me. Very excited to be here.
Well, me too. And the reason that I wanted to have John on the show was that I've been familiar with this brand line for a number of years, but I always, equated it as being a trenchless solution, primarily for pressure lines in gas and water, utilities. But have just, come to find out, learn something new every day, is that this also has some applications for large diameter wastewater lines where there's big flow. And so, John, I'd like you to kind of help me to educate the industry who may not be aware of this application and how Primus Line and its technology can be applied for wastewater, its most ideal applications, because as we all know, there's no, magic bullet, one size fits all, right. And where it can really shine and help asset owners who may be looking for a solution for an application such as this.
Correct. Yeah, absolutely. So, most of the industry does know us for potable water applications. That's true. Raw water, those sort of things, high pressure lines. And this product was originally designed for the gas market, right? So we see these very high pressure ratings that you don't normally need or require in a potable water application. And again, sewer force mains tend to be, and that's really our primary application in the wastewater market is going to be sewer force mains. About 5 years ago, we did some parallel sludge lines at a plant up in Hartford, Connecticut for Hartford MDC. That was during a plant upgrade, and they had several lines that were running under a thickener building, and they couldn't be dug up. It was impossible. And there was too many bends to do with conventional CIPP lining. It wasn't really even possible. And the downtime was, going to be a significant problem for the plant. So they couldn't afford an extended period of shutdown. So they started talking to us. We had done a bridge application for the city of Hartford MDC with this product. And when they came to us, we looked at it. So every project that we look at, whether it's for potable water, whether it's for gas, whether it's for wastewater, still has to go through our engineering process, right? So we'll go through the process, and most engineers and I'm sure you're familiar with it too, we send out a data collection sheet. They fill that out, and we give an evaluation. But sometimes that's like a 10,000 foot view, then comes down to 5,000 as you move along in the process. And so we keep on redefining and defining the application to make sure that every single application is going to be successful. So Primus Line has been around for over 20 years now. We've got over 850 miles of this pipe in the ground worldwide, and there's been zero failures to date. And we intend to keep it that way. So it's critically important that we get this process done up to the installation and all that process is done in conjunction with our engineering department. So that's sort of different about our product. And like you say, we don't feel like there's any silver bullet, for a solution out there. And we certainly don't claim to be that either. But where we do work, we work extremely well, and we can usually save clients a significant amount of money. So where we see it is very long runs, multiple bends, which are kind of ideal without a lot of connections. And that's where sewer force mains make a lot of sense for us. So in the particular instance, the sludge line in Hartford, there really was no other option. We were an ideal solution. So we were able to get that done in 3 days' time between cleaning, lining, installation, put back in service. So they were only down for 3 days on that line, and they were able to internally bypass, but they couldn't have kept that going, that way for long. So in these instances, there's, certain niche applications, and then we look at sewer force mains and where does it make sense. So you have pinhole leaks in your line. If you have leaky joints, this is but you've done a pipe condition assessment and your hose pipe is still capable of maintaining the ground load, then we're an ideal solution. So that's primarily the number one application in the wastewater would be the sewer force mains. Of course, anything over bridges, aerial crossings, all those are also ideal applications as well.
Well, now when you were saying that it's flexible and it requires, a very small footprint, so we're in a little bit, we're going to show an animated video of the actual process. But how does this compare, where you were saying with the multiple blends and sealing the joints? Does it actually adhere to the walls, or is it creating, similar to that thought process of a slip lining or CIPP, a pipe within a pipe? If we were to compare it so that people can understand, that everybody understands what that is. Sure.
So, we can oversimplify it a little bit by saying, if we use AWWA's classification, we're somewhere between a class 3 and a class 4, right? Because we are handling all of the structural, pressures. We're handling that. Exterior loading, we're not taking that into consideration. The hose pipe simply becomes a conduit for our liner. In other words, once we pull our liner in, the process is we pull this in. It's an advanced form of slip lining. We fold up the liner into a C shape. We tape that up, and then we pull it in. We talked about the small footprint. So our pipe comes on a spool. So you're already talking about a reduced carbon footprint when you're talking about the transportation and handling of the pipe, because we actually fold it up. So there's no wasted space. We're not shipping air, right? We fold it up. We put that on a drum, and the drum can be from 3 meters wide or 1.5 meters wide up to 11 meters wide, depending on the application. So again, there's a lot of versatility and flexibility with Primus Line as it relates to a specific project. Sometimes it requires a 10-ton winch to pull it in, right? So other times it could potentially be pulled in by hand. So we've had actual projects where it was 90 feet in length, and that product was actually pulled in by hand. But you couldn't have gotten any of these other technologies in place, because this actually can snake into those spots. We then pull it in place, we inflate it, put our end connectors on, and in the industry you hear the term end seal for other conventional technologies, and we're not an end seal. Ours is a connector. So the difference between us and other technologies is that we guarantee 100% leak-proof connections from point A to point B, right? From end to end.
Well, how are you able to do that?
So the way we're able to do that is really through our connectors. So we have a German standard and an ISO standards that we have to conform to. So every single line, the quality control and quality assurance that is taken during the manufacturing process is really second to none in the world, because we actually, as we manufacture it during the entire process, from bringing in the material, the pellets that we use for the polyethylene coating on the inside and the outside, all of that is gone through quality assurance, quality control. So all that virgin material is processed. It's brought into our extruder. We have a loom that manufactures the weave for the Kevlar, creating the tube. And then we have two co-extruders. During that process, we have these optical sensors that are measuring the thickness circumferentially during the whole entire process. If anything comes out of spec, that thousandth of an inch, it's going to stop immediately. We're going to rectify that problem, rectify that situation, and then we go ahead and continue back into service. So it's really and when we manufacture it, we take a sample and we do destructive testing on that liner. And that's a requirement. That's that part of that standard, especially for gas, is we have to document that. It's uploaded to a secure cloud and can be accessed by the German government for verification. And it's videotaped. So we do destructive testing. We use our end connectors with the liner, and we test that to failure. And the liner will fail every single time before the connectors. And that's an important distinction, because that's the number one area where you have problems with conventional rehabilitation methodologies, is where it connects back to the hose pipe, right? So, and that's the difference. The distinction is we're not sealing the ends, we're connecting it back to the hose pipe as a transition. And when I show you the video, I'll sort of go into that a little bit more.
Okay, well then, since you did that, I'm trying to wrap my head around and visualize this. So why don't you go ahead? You have share screen capability. Why don't you go ahead and take us through that video and explain what's going on the screen for those of us who are just tuning in sound only.
Sure. So this is a typical application. It might be a siphon, sewer siphon, for example, going underneath the river, and you're going to have typically you have multiple 45-degree bends to have that line traverse underneath the river. And so you're seeing sort of a three-dimensional sort of cutaway of what that looks like. So you've got a 30-degree bend coming up to the line. So you have vertical and horizontal bends. So a real challenge for a lot of, other slip lining technologies. And again, that's sort of the benefit of having a flexible liner like Primus Line. So we come to the job site. You see the spool that's on there. We've prepped the job site. We've cut into the hose pipe. Our footprint, as mentioned, is much smaller than other conventional slip lining technologies, because our liner can be pulled in through at a 90-degree bend, inserted at a 90-degree bend. When we pull out at the target pit on the other side, we typically like to be between 0 and 10 degrees. So that might be a little bit elongated, but typically we need about 5 feet of actual workspace inside the pit between the end cuts of the pipe, of the hose pipe. So then you're going to need 2 feet beyond that. So you're talking about a 9-foot diameter pipe by about 4-foot wide pit, typically is what you see for our access pits. So the liner is pulled in. We're going to do a CCTV inspection to establish the condition of the hose pipe. Then you're going to do the cleaning. And for, cast iron pipes, which makes up a good majority of the pipe here, that's ductile or cast, it's going to be cleaned with a scraper, and we put squeegees in behind that. And everybody's familiar, most people in the industry are familiar with that. You don't have to do it that way. You can jet the line or pig the line. There's a lot of different ways to accomplish it. Our requirement means that for the cleaning, the hose pipe doesn't have to be perfectly clean. We're not getting down to bare metal. Our main concern is that there's nothing in the line that can damage the liner as we're pulling it in. And you see we use a pulling head there. You don't always aren't always required to have a pulling head. Sometimes just a steel rope. So you're seeing there the insertion of the pigs to inflate the line. The line's been inflated. It goes back to that round shape, and you're putting on the connectors. And at this point, kind of brings, I'm going to pause it right here. So why we call it a connector is you can see that the hose pipe has a flange placed on there, and it's typically a 150 ANSI flange. So it's a standard flange using a multi-joint adapter. You can accomplish that, or you can weld a flange on there. But whatever the case may be, we're going to bolt up to that flange with our connector. So you have the outer sleeve, which is this portion right here in white, and then this blue flange bolts back to the hose pipe. The liner is then pulled in, we re-round it. So with Kevlar, which has about 5 times greater tensile property than steel, it can only get to that roundest OD that we advertise, and it simply can't go anymore. There's no saturation of that line. So it's our liner. I don't want to confuse it with other technologies that might be out there and act like a bladder, for example, and will expand to the hose pipe. We're not tight fit. We're intentionally undersized. We want to stand off of the hose pipe, so we're not transferring any energy back to the hose pipe, whether it's water hammer, whether it's any of these dynamic forces or movement. If you're on a bridge, your hose pipe is going to be subjected to axial forces, longitudinal forces. All these things aren't going to affect our liner. We can accommodate them very easily and do all the time. So in fact, there's applications in Italy, for example, they use our liner specifically for seismic upgrading of existing lines. And that was in Trenchless Technology a couple of years ago, a big article on that, interesting. And that's on our website. So seismic upgrading is a huge application for us. Anywhere there's a lot of movement of the hose pipe and you're concerned about, cracking, shear force, any of these things, really don't impact our liner significantly. So, but back to the connector. So why ours is important. We use the stopper, right? Inside stopper. We inflate that, blow it up, and we basically re-round it to the inside of this sleeve. At that point, we're putting in our core, and the tolerances here are very, very tight. So we're placing in this core, we're restraining it with some come-alongs, so you're making sure that it doesn't move. We have a 2-part epoxy resin that we'll inject, and you can see there's a slight void that's manufactured into this core. So the 2-part epoxy resin that we use in this process never comes into contact with our liner. And that's important. That's an important distinction. This becomes a mechanical lock. So you'll see that there's a relief cut into this core piece. So what's going to happen, we're going to use a high pressure hydraulic pump forcing a hydraulic cylinder to press this mixed epoxy into that void. And what's going to happen is it's going to crimp the liner in between and seal it in between the core and the sleeve. And then it's going to cure in 6 hours. In 6 hours, once it's cured, it's ready for pressure. And that's good for about 1,000 PSI. I mean, that's never going to fail, and it's never going to come off. It was designed for gas applications. So as you can see, we're using that high pressure pump to inject the epoxy. That epoxy is pushed in under about over 1,200 PSI. So it's actually deforming the metal, reshaping it, crimping it. So that is now ready to go after 6 hours. That can be pressure tested and put back in service. Once that's done, you're ready to put your spool piece. You've done your hydrostatic test. You've done all your testing. You've passed your test, and you've passed your, for this, you don't have to worry about bacteria, but You're going to put that back into service and it'll be operational in 6 hours. So in certain instances, we'll have, like on sewer force mains, you have air release valves at the high points, right? So what we'll do is we can actually pull, and usually sewer force mains tend to be longer runs. So we can pull up to 8,000 feet of liner in at one time. Typically, when you have the high points of the sewer force mains, we have the air release valves. When you're rehabbing the lines, it's my experience been pretty typical that they'll replace the air release valves and put in new ones anyhow. So we'll take those air release valves out, remove them out of the equation, and then we'll just pull straight through that section.
Okay.
And then we cut back our liner, put those end connectors on, because anywhere you terminate our liner, you have to use that type of end connector.
Understood. So as far as diameter of lines, obviously you can go long runs. It almost sounds like it's unlimited. How about the diameter of the line itself?
So we're in a range of 6-inch up to 20-inch. Now, when you get to larger diameter sewer force mains, it is possible. We have done it. We've done it all over the world. We've done it in the U.S. now. So we've done multiple lines in a single line. So the capabilities of Primus Line. So we developed this technology. We own the manufacturing of the technology. We have basically a mechanical engineering shop back in Germany. So we manufacture all the parts and pieces here, our connectors. So we can custom manufacture a manifold, right, for multiple lines when it works, when it's appropriate. And it doesn't always work. Oftentimes with sewer force mains, people can live with a reduction in the flow, if it's an increased use of pump, whatever the case may be. But what we do for sewer force main applications is to make sure that they run properly. We have a checklist that the owner and engineer will go through, making sure there's a non-return valve at the bottom, right? So as the pump comes on, we want to maintain a full flow in the line at all times. So anywhere you're coming up where you have a transition to gravity sewer, for example, we want to make sure that our pipe stops before that transition, if that makes sense.
Mm-hmm. Okay. All right. So now, are you strictly the manufacturer, or do you also do the installation?
So in Europe, we actually do installations. We have crews that do the installations, right? So we've pioneered the technology. We've mastered the installation. But in the United States, we have partners that we work with. So and it makes sense. Like you said at the beginning, we don't feel like we're a silver bullet. We could solve everyone's problem. I wish we could. That'd be great, but we simply can't, right? And we understand where the applications are, and we have no interest in selling a product for an application that doesn't make sense either financially or physically, fundamentally for an operator. So if you look at some of the work that's gone into, or an ISO company as well, so our installation manual is incredible. Our part of the closeout documentation that we give to the owners is an operations manual, right? So we give a 5-year warranty with with every single installation, and that's part of our partnership, the CSPs in the U.S. And what we did earlier this year is partner up with a company called MTC. So they're part of Aegion, and one of the biggest hurdles we had here was not being able to get material in the United States quick enough for it to be practical. So, for example, we did a project up in Montana. It was a 6-inch sewer force main running through a river, and it had been leaking. And so the contractor was racking his brain. They had divers, and they were trying to put bands on the outside of the pipe. And there was still the raw sewage was flowing into this salmon river, right? So you couldn't have it. It was a real problem. So I got a call on a Sunday afternoon And the contractor said to me, do you have, it was 800 feet of 6-inch liner in the US. And I said, well, we don't stock anything in the US. Back at the time, we didn't. And I said, but one of the contractors might have some, and he was in Connecticut. He'd done a big project in Connecticut, and he had the extra liner with the 2 connectors. And so I put those 2 together. They had the discussion because you need to be a certified installer. They weren't, but they knew about the technology. And this was a real emergency, and they needed a solution right away. They couldn't wait 8 weeks or 10 weeks, whatever it would take to get from Germany. They simply couldn't wait. And I understood that. So they actually flew that night. They talked, and they flew one of their guys to Connecticut. They rented a truck, picked up the material, drove it to the job site in Montana, and they flew. The contractor from Connecticut flew there, and they actually installed that line, and it was done in 1 day.
Wow.
So had the phone call on Sunday. That line was up, operational, leak-free by, I want to say, Wednesday.
Wow.
So it was really sort of an amazing outcome, and it exemplified why we needed to have material on the ground in the US, because you can do things that quickly. And we do a lot of bridge jobs. One of our CSPs, J. Fletcher Kramer, for example, does a lot of work up in New Jersey on bridges. They have lines that are, potable water lines that have been, because of the freeze and thaw and the heavy traffic on the bridges, the lines have failed, and they've been rehabilitated with other technology, and they still fail because of the movement, and it's a rigid pipe bonding to the host. So if you're bonding to the host pipe, as goes the host pipe, so must go whatever's bonded to it, right? So if it can't handle that movement, it becomes a problem. So for us, it's not an issue for us at all. So the applications keep on growing. We've had, vertical applications in excess of 900 feet. So all these applications are, our engineers love to get their heads wrapped around these exciting challenges. Everyone gets bored kind of doing the same thing over and over again.
Well, John, I want to thank you for coming on the show and, giving us I guess, what would you call this? Kevlar. How do you describe this line, kind of a 101? I mean, it's not CIPP, it's not slip lining. I guess it's a form of trenchless technology.
Right.
What would be the best way if you were to give a term to it, or
So I mean, we call it most of the time we call it, Primus Line, right? Just for
right.
Primus Line thing. But so a generic term for this would be a flexible fabric reinforced pipe, right?
Okay.
FFRP. So that's sort of the generic distinction of it, of the terminology. But again, we have the important distinction to remember is that we're a Kevlar liner, and really all the strength, all of the product's capabilities are derived from the connectors and the Kevlar weave, and that's what sets us apart.
So it cures then in the line, correct?
No, there's no curing, and that's it's all about risk mitigation. When engineers understand our technology, and once they get their heads wrapped around it, and they say, "Oh, wait a minute, I'm not building a pipe in the ground. That pipe is already made. I'm simply using air to inflate it, go back to round shape." That's all they're doing. There's no cure. It's already done. That's why we can turn around the project so quickly.
Okay, so once that pipe it's inserted, that liner is inserted, and then it's inflated to that round shape.
Yes.
Not to sound silly or dumb here, but what makes it stay inflated? You can't keep the air pumping in there.
Right. So we're still pressure applications, like for sewer force mains, and that's why we use the non-return valve at the end by the pumps. So what we'd want to do is maintain at least a full flow in the liner, right?
Okay, so it's the actual flow of the line itself, because it's a pressure line that actually got it. Thank you.
Yep. You're welcome. It's a legitimate question and trying to going through the process of understanding. I get
it's the pressure. It's because I could see how it would do it underwater. I see with gas, but you was so okay. Gotcha.
But still, just so so you can understand, and some people, think of this as just sort of like glorified lay flat pipe, and it's not, right? So we'll still maintain a round shape even if there's nothing in the pipe. So if the pipe runs empty, our pipe will still stay round. It's not designed to handle any exterior structural loading. Your hose pipe is still taking that on. So, but the important distinction to remember here is, like, for a sewer force main, right? You're going to have interior corrosion, and that's what's causing these pinhole leaks and everything else from the H2S gas that's building up in the line. So as we design, right, these things, we're actually removing that from the equation, because there's not going to be any air trapped except at the air release valve. It's going to be a full flow the whole way. So we're taking on all that scour and abrasion that would be fully, further degrading the pipe. We're halting that process. So essentially we're freezing that pipe essentially in time, or we're slowly halting the process of degradation significantly. So we have a 50-year design life is for our pipe.
I was going to ask you that. Okay.
Yep. So when we talk to pipe owners, asset managers, and asset owners, we explain to them, when it's a partnership, and you need to understand the conditions and things that are causing. And we ask the question, what problems do you have that we're trying to solve? Is it shear breaks? Is it, longitudinal fracturing? What's going on? So helping them understand. AC pipes, we do a lot of AC pipes in the U.S. We see a significant amount of that. And so the hose pipe, at the end of the day, the material is irrelevant to us. We don't care what it is. It just, if it's going to be a line that we're aligning, we want to make sure that's got structural stability, right? Some life left in that. But people say, well, what's going to happen? Is that pipe going to just eventually disappear? What are you going to be left with? Well, the reality of it is, if it's cast iron, we have cast iron lines from the 1880s that still look better than pipes from the 70s. So it all has to do with that's why every job is unique. We go through and we're the first ones to say, if this isn't right, we're not the right application, for sure.
Well, John, thank you. This has been fascinating. Learn something new every day. I'm so glad you came on the show. One more thing that I know about that it's really, really interesting. And I like how, the manufacturer has seen, all right, we started out here with this one application, but wow, how we could extend ourselves to be a solution.
Right.
And that, like we were saying earlier, there's not one magic silver bullet, but it seems like this is something that has great promise and can be a solution in those really tough spots when other trenchless technologies just, not because they're not good, but just they weren't designed
for that application.
And infrastructure is probably as variable as fingerprints in human beings. Like no two systems are alike. So again, John, thank you for coming on the show. And for those of you who are interested in learning more about this, you can visit the Primus Line website, which is primusline.com. Correct, John?
That's correct.
That's correct. And I would encourage you to connect with John on LinkedIn, and that is John Moody, Moody, with Primus Line. And again, thank you for tuning into this week's episode. And until next time, keep it flowing.
Take care, everybody. Thank you.
Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.